Today we have implemented half adder using logic gates. Here we have taken two inputs, which is A and B, and as we know, it generates two output, carry and sum. So we have denoted the sum with this LED and the carry part with this LED. When we come to see its truth table, these are all the all the possible combinations, that is 0 0 0 1 1 0 and 1 1. When we add two bits, 0 plus 0, the sum and carry part, that is 0 and 0. 0 plus 1, the sum becomes 1 but carry remains 0. When we add 1 and 0, the sum becomes 1 but carry part remains 0. But when we add 1 and 1, 1 and 1, that is 2, so the sum becomes 0 with 1 carry. Now we will come to the expressions, boolean expression. For our sum part, when we see from the truth table, we deduce that the sum is A XOR B, which is A dash B plus A B dash, which we can see from this truth table, from the value 1 1 from here. And for the carry part, we have from this value A dot B. So from expression we can see that we need one XOR gate and one AND gate for our demonstration. Now we will come to the diagram. As we can see that the logic diagram of our circuit, in which we have used an XOR gate and an AND gate. Now we will come to the circuit.
Okay, so now we will understand the implementation of this whole part to our breadboard. So here we have used one XOR IC, which is looking just like this diagram. So here are four ICs in the XOR, four XOR in this IC, IC7486. So here we are using only one. So the input pin of this XOR IC is 1 and 2, and the output is connected to the VCC or the ground, whatever we have to our input combinations. Similarly, we have our AND IC, IC7408. So here we're also similarly like the XOR IC, we have our 14 inputs, but we have only used 1 and 2. So when we use 1 and 2 and this XOR 1 and 2, so we will now try to visualize the connections of this IC. Let's take it. So okay, now we will understand the wiring of this breadboard. For this XOR IC, we have our inputs 1 and 2. So from the diagram we have 1 and 2. So we have wired this 1 to the AND gate of 1. So this wire goes from XOR IC1 to the AND IC1, and this 2 of XOR IC to the 2 of the AND IC. So this is also from the 2 of XOR to 2 of AND. So now we will understand that the 1 and 1 inputs are also connected. So the XOR we have having the first input to the 1, which is the black wire, and this B is going to the 2 of AND IC. So this red wire is here for our B. So now what we will understand is that how the inputs and all the things is working. So we have to connect a source battery of 9 volts. Here we have connected, and we will connect to this here, and we have also connected this so that the whole breadboard thing is going to be for common purpose, and the whole ground, and we can use whole the workspace area. And we have also connected this 14. From this diagram we can see that this 14th is connected to VCC. So the VCC of 14th AND gate IC and OR gate IC both are connected to this VCC, and here we can also see that the 7th part and the 7th part is connected to the ground of the breadboard. So this 7th part of the XOR IC and this 7th part of the AND IC is also connected to the ground. We have also connected the LEDs, and for these LEDs not to be short, we have given 100 ohm resistors to this so that the LEDs can work properly. So now we will see how the whole thing is working. Okay, we will now try to visualize the output thing. As we have discussed earlier, this is A and this is B. So my teammate will connect to the ground, for the 0 purpose. So the both the outputs inputs A and B are connected to 0 0. And now we will see the nature of S and C. As you can see, the power is now given to the breadboard, but after connecting A and B, both the lights are off. So both the lights of S and C are 0 0. So it's depicting 0 and 0 nature. So now we will understand the second case of 0 and 1. So one of the inputs, that B, specifically B, to be connected in VCC to give the power, and now we will turn on the power source again. So the sum is going to be 1. The sum LED is now blinking. So as you can see from the truth table, it's also verifying that the sum is 1 and the carry is 0. So now we will again see the third case for our A to be 1 and B to be 0. So for this, the sum should be 1 and C should be 0. That is, carry should be 0. So now we will see that in this case also, when A is 1, A is connected to the VCC, and B is connected to the ground, which is 0, the sum is going to be 1 and the carry is going to be 0, and the sum LED is now blinking and the carry LED is not blinking as always. So now we will see the last case of both A and B to be connected to the VCC, and both are connected to the VCC, that is 1 and 1 specifically. And now when we will give the power source to the breadboard, it will show that the sum is now 0. That is, this LED is showing the sum, which is 0, which is not blinking, and the carry part is 1, which is blinking. So by this we can conclude that the half adder is now our working process, and all the things here we have discussed is properly working, and I hope you will understand this. Thank you.